designed to extract a attack signature in a very efficient manner. For example, early burden autograph are all along this approach. There's also many honeypot-based approaches like HoneyD, HoneyNet, and here there's also some very extremely exciting, interesting work on collapsor and vground, understanding the behavior of the malware in a virtual machine environment, as well as maybe attracting all kinds of malicious traffic into one spot, into this vground. And there's also a large body of work on network intrusion detection, such as Bro, Paxton's work, and Snort, as well as traffic normalizers. Basically, in the intrusion detection system, usually it's on the edge network. There could be a discrepancy. Because you're in the network, you basically have to reconstruct the protocol context from the network layer up. So that can be very challenging because you're not exactly at the end host, and people can play various tricks to evade the detection. So then there's techniques like traffic normalizer being introduced, trying to normalize the traffic so that the intrusion detection system can analyze the traffic in a more accurate fashion. So basically, I think for worm defense, for malware defense, we need all kinds of defense mechanisms playing together to be effective. And the shield, what's special about shield is that it's an unhost firewall. It does not need to reconstruct the protocol context from the network layer up. And by being intercepting the transport layer and up, basic application layer traffic, we only need to deal with the application level traffic. And it's also more efficient that way. We don't need to touch the traffic that belong to the legal traffic, to the traffic that belong to that do not have software defects in them. So there's some ongoing work in the Shield project. Our most recent work is basically going further on the generic application level product analyzer and its language design. Basically, this mechanism can be a general mechanism for not only the intrusion detection, firewalling. It can also help with the network monitoring, help you analyze the protocol traffics, the application level protocol traffics, helping you maybe annotate the traffic with application level protocol semantics. I believe there are some other more interesting applications there. For example, we can also combine this kind of protocol understanding logic along with some unknown zero-day exploit detection mechanisms to potentially allow automatic signature generation, like Shield kind of signature generation. Some other ideas we have is having a Shield pod instead of. So basically, we have a Shield-enabled detector, basically for detecting stealthy or polymorphic attacks for the known vulnerabilities. So in the future, we believe that there will be that the stealthy worms would be much more difficult to deal with. So just to conclude, Shield is vulnerability-specific exploit generic network filters for preventing exploits against known vulnerabilities. And we use generic protocol analyzer as a key mechanism. And we use a session and message-based inspection rather than packet-level inspection. We use a CIF description language to specify the policies. And our initial prototyping and evaluation results are quite encouraging. Thank you very much. I believe I'm quite early.
We have time for
a lot of questions. Yes.
Can you give an example of the vulnerabilities Shield is targeting other than the buffer overflow attacks?
Yeah, that's a very good question. So basically, here you can think of our mechanism here is to understand the protocol context. With that knowledge, you can do a lot of things. Sometimes, for example, your protocol may have some logical errors. For example, it doesn't have authentication stage. Presumably, you can insert that authentication logic into this protocol state machine and to fix that logic problem with the protocol. So basically, any vulnerabilities that's at a network level, because we understand the protocol context, we can do something about it.
Is there an example where such has existed or?
Yeah. Yes, there is a vulnerability. I think it's in a university plug-in and play. So basically, it's a logical error in the protocol. And we can potentially insert a small state machine to deal with that vulnerability. Of course, for buffer overrun, even for buffer overrun, it's not necessarily that easy. It's not always easy to deal with, depending on where the buffer is overrun.
I mean, lots of people have worked on buffer overflow, and for most part, it's done at various levels, and it's solved. I mean, if it's used, all those techniques are used, then it shouldn't be a problem with that buffer overflow. I mean, it's different.
Yeah, so there are different approaches, right? You can use software patching to fix to basically insert the check, the boundary check in the source code directly. But there's some problem with that approach. Even with stack guard.
It is at the language level, it is at the OS level, at the hardware level. So, I mean, it's solved at various levels, and putting them all together, it should basically solve the problem.
No, it doesn't. The problem is it does not solve the problem.
Those are not used, that's why it's not solved. But
that's not true. That's not true. For example, for the non-executable stack, the return to libc problem can still evade that. So basically, there's basically various attacks to work around the mechanism like stack guard or non-executable heap or stack. It's true that when you have all those mechanisms in place, it can stop a lot of buffer overrun-based attacks. But it's basically an arms race. There's always a new attacks circumventing those mechanisms. But here the key advantage of our approach here, we have a vulnerability-driven approach. No matter how you vary your attack vector, no matter how you vary your attack, we can protect you at a more fundamental level. Yeah?
My question is, if you have a vulnerability, will you be having only one kind of attack? I can use that vulnerability with different approaches, right, maybe?
Yes. You can have many different attacks against the same vulnerability.
So the thing is, then you will have only one state machine for one vulnerability?
Yes, there's only one state machine modeling it's really modeling the network operation aspect of that application. So basically, no matter how do you vary the attack, you can still exploit the same buffer. You may have different content. The payload, malicious payload, you can have various malicious payload to overrun that buffer. But no matter how you do that, we're checking,
And this is true for buffer overflow.
I don't think it's specifically. I don't think this is specifically for buffer overrun. Basically, we provide a mechanism that we can show you what the protocol context is. Based on this protocol context, you can do whatever you need to do to protect your system. Sometimes it's a buffer overrun that you need to do. You basically do a boundary check at the network level. Sometimes it's a protocol logic problem that you need to insert, a partial state machine into the protocol state machine to basically correct the protocol logic problem at a different place. Yeah.
Couldn't there be two paths through your state machine to get to?
Yeah.
So wouldn't that be two protocols for the same vulnerability?
No, it's still this. So if you look at this protocol state machine. If you look at this protocol state machine here, there are many different paths that can lead to that vulnerable state. So by specifying that state machine, you captures all the possible paths that leads to that state, all the possible sequences of methods that lead to that state. Yes?
Just a question more. I mean, there was one worm before that was the Outlook, I think it was, had the preview mode where, people viewed it and, the preview automatically viewed the attachment and it sent itself off. Would this be able to be used to do this, since that's kind of past the protocol?
I think for email I don't think email viruses or email worms is really a big threat today. I think there's a easier solution than this to address the email worms and viruses. You don't do the preview pan, then you will not be so automatically exploited, and then you use antivirus software to scan the email content and to figure out whether you have a virus contained and cure the problem there.